Solve quadratic inequalities graphically. So here we have four interesting cases. The first one is x minus 4 whole square less than 0. The other one is x plus 3 whole square greater than 0. Then we have x minus 5 whole square greater than equal to 0. And the last one is x minus 1 whole square less than equal to 0. Now these quadratic functions are slightly different from the ones which we had in the previous example. As you will notice, we only have one factor. In fact, we have only one root and there's a double root, right? So both the roots are at one place. So let's list our roots in each case first. X minus 4 whole square less than 0. So where do we have a 0? We have a 0 at x equals to 4, correct? In this case, the 0 is at x equals to minus 3. And there is only one 0, correct? And in part C, x minus 5 whole square greater than equal to 0. The 0 is at x equals to 5. And in part D, x minus 1 whole square less than equal to 0. The 0 is at, when you equate x minus 1 to 0, you get your 0 at x equals to 1. So the interesting part is these are quadratic equations which have only one real root. There are two roots at the same place, right? So both are at 4 in this case. Now, if you sketch it, then our vertex is going to be on the x-axis. That's the whole idea, right? So let's sketch them all one by one. Now let me just sketch them here, and then we'll find the solution, right? So the first one is x minus 4 whole square less than 0. That is the inequality. But how are you going to sketch the function x minus 4 whole square? It means that the parabola has moved 4 units to the right and the x-intercept is on the x-axis, right? And this point is at 4, correct? And of course, the vertical axis is somewhere on the left side. So let us say there it goes, right? Anyway, when we are solving inequalities, I'm trying to make a rough sketch and we are not really bothered about the y-axis. The idea is that when you plot your graph for the parabola over the 0 or with two zeros, as we did in the last time, each 0 divides the plane into different intervals. So one 0 will divide it into two parts, as you can see, right? So we have one part to the left side of 4, the other one to the right side of 4. Now the inequality is x minus 4 whole square less than 0. So which part is less than 0? Well, the minimum is at 0 itself, so there is no solution. The whole graph is above the x-axis, right? So in this case, we have no solution, right? So at times, you may have inequalities where we may not have any solution, right? Since this is either equal to 0 or greater than 0, we have no solution in this particular case. Now let's look into the next one. It says x plus 3 whole square greater than 0. The 0 is at x equals to minus 3. So if I draw this graph, it will be shifted 3 units to the left, right? Well, I'm not showing you the y-axis, but I'm writing the zeros here, and this 0 is at minus 3, right? Now, for your convenience, you can always plot it as, x and y plane, right? Okay, now the inequality is x plus 3 whole square is greater than 0. Now you tell me, what is the solution? Can you sketch the solution on a number line? So let us say this is my number line. Then how can I sketch the solution for this inequality? Well, as you can notice, we are looking for greater than 0, not equal to 0. So minus 3 is not a part of solution, but all other real numbers are part of solution. Do you see that? So that is the solution. Everything except for minus 3. How will you write it in the set form? In the set form, we can say x belongs to real numbers so that x is not equal to minus 3, but everything else. So that is how you can write your solution in the set form. How will you write your solution for part A in the set form? That is a question for you to answer. Well, as you know, this is a null set, right? So you just draw like this. Nothing inside. That means a null set, right? Represented by phi, right? So that is a null set, and that's a solution. Nothing inside. Do you see that? So parabola is always positive. I should say non-negative is 0 or greater than 0, right? It is never less than 0. When you square a number, you get a positive number. Perfect. Now I think that should help you to answer the other questions. Okay, let's move on with them. So this one is x minus 5 whole square, and we know it has to be positive, and 0 is that x equals to 5. So this time I'll sketch my graph, which will look like this. Move 5 units to the right. But what is the solution here? The inequality is x minus 5 whole square greater than equal to 0. That means everything, 0 included, right? I mean, do you understand what I'm trying to say, right? So it is all the real numbers. On a number line, well, when you draw a number line, you will draw the whole line and you say, well, this is my part of solution. Everything included. Do you see that? Nothing excluded. And we'll say in set form, x belongs to real numbers is the solution. So this parabola is always positive or 0. It is non-negative. So the inequality is x minus 5 whole square greater than equal to 0 means all real numbers is a part of solution. Now the next one for us is x minus 1 whole square less than equal to 0. Less than equal to 0. First let's sketch, right? So when you sketch it, you get a parabola like this, which has a 0 at 1, right? Now it says less than equal to 0. We know it is never less, but it is equal to 0 at 1. So we have a solution here, and that is x equals to 1. So this is the part of solution, and on a number line, you can of course show the solution at 1, right? So this is 0 for us. Say this is my 1, and that's the part of solution, correct? This is the solution. So remember one thing, that if you have a parabola with vertex on the x-axis itself, in that case there is a possibility that we may not get any solution, or we may get just one solution, right, as we got in these cases. So these are kind of special cases. We'll explore some more equations like this and then see what happens when we use the quadratic equation in vertex form or some other form. Okay, but I hope you learned from this one. So remember one thing, what you learned here is at times there could be no solution to the inequality, and phi set or an empty set like this, that's the way to write your solution, right? Because you're supposed to write solution in the set form. Now, or you may just get 1 point as a solution. So x value at that point gives you part of solution, right? So whenever we are looking for solution of an inequality, we are looking for range of x values which will satisfy the inequality. That's the gist of it, right? So let's move on to the set of quadratic questions, inequalities, where we'll do the factoring and then find the solution graphically. Thank you.